Hello everyone. Good evening Siddhi. Good evening Devika. Good evening. Good evening Prashant. Good evening Pratiksha. So yesterday we talked about yesterday we talked about a very important technique known as binary search on answer. We actually just ended it on binary search on answer. I believe there was one question that we were discussing known as Koko eating bananas, I guess. That was the first question of binary search on answer. So I think we should begin. So good evening, Gaurav. Good evening, Beer. Uh, yes. So welcome everyone to the day 4 of this boot camp. So how many topics are left? We will be talking about binary search on answer, and then we will be talking about uh, sliding window. There are some really interesting problems of sliding window. In general, how do we implement sliding window? These two things are left. So we will be talking about them. Hello, Afsal. Hello. Did you guys hello Rohan. Did you guys try to solve this problem? Did you guys come up with any observation or something? Any observation? Even if you didn't try, even if you didn't come up to an answer, any answer, did you note any observation in this problem? The problem was, let me just share the screen. This was the problem. Try to think of the answer. Try to think about some of the observation. Tia says binary search for optimal. Yes, exactly. We need to binary search for the optimal value of the. So essentially, I hope that my screen is visible to all. See, simply, what was the discussion? The discussion was that if there exists, for example, if Coco cannot finish all the bananas using the speed of 3, then we know that she will also not be able to finish them with the speed of 2, right? Like if the answer for this is false, the answer for this will also be false, and for this it will also be false. We know if there is a value such that the answer is true for it, like it can finish eating bananas less than equal to h hours, then we know the answer will be true for these many values, all the values more than them, right? Because if we find a speed for which she can finish eating bananas in h hours, then any speed more than that speed will also be the answer, right? So it is kind of something like this: not possible, not possible, not possible, 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 possible. So think like it like a monotonic function. It's like a function which goes up like this. It's like a monotonic function, right? It's like a monotonic function. Like it's 0 for them, 1 for this, right? What we can do in this problem is we can apply binary search on the answer. Why? Because we know that it follows a monotonic pattern. So let's try to code this. Divide by 2. Hours for entire equal to 0. I less than files dot size is this. Mm, Oops, it says time limit exceeded. Why do we say time limit exceeded? Hmm, did I make any error in this? Yes, now it's clear most probably. I hope it should be accepted. Oops. It was something- Maybe we should make every entity. More precisely, we should make this entity. Let's see if it works. Good evening, Yuvraj. Good evening. We Yes, it gets accepted now. So this is the code for the problem Coco eating bananas. If you have any doubt, you can ask it in the chat. If you have any doubt, you can ask it in the chat. Otherwise, we go to another problem, another very interesting problem. Step by step explanation of the code. Okay. Any other doubt? Clear for now. Show the code. Okay, so I believe most of you are requesting for explanation for the code. Okay, let me just explain the code once again. These are the limits of the answers. These are the limits. Okay, so S denotes all the values equal to S and less than S. It is not possible to choose that speed. And E denotes every value equal to E and greater than E will always satisfy the condition of eating all the bananas. Okay. So we know trivially that if we put E to a very large number, then then it will satisfy, right? Because for a very large number of speed, Coco will be able to eat the bananas, right? It will basically tend to zero. If, imagine it like this: if her speed is infinity, then she will take like what? Something divided by infinity is zero, right? So for ith pile, it will take zero time. For second pile, it will take zero time. So it's kind of like very less time. So that's what I have done. I have initialized my e variable, which denotes the second pointer to a very large value. So, and this is a simple binary search operation. I don't really think I need to explain this. This is my variable. This is checking. This is the current speed, right? Speed. This is the speed, and it is checking the number of hours Coco is taking for this speed. Okay. Now, if these number of hours are greater than h, which we don't need, then we initialize s equal to speed, right? Because what s was, s denotes the pointer behind which and including that every speed is, we can't take that speed, right? So we initialize it with s. In any other case, which is the case of h less than equal to, in that case we initialize e with speed, because e denoted every speed greater than e and equal to e is always a viable speed, right? So that's how we are dealing with these two pointers, and then we are returning e. So I hope the code is now clear to all. uh, Now I'll be going to another problem, which will be this. So just read it, everyone. I hope everyone has read this problem. Try to think of any approach you can apply. The attendance link is up on the chat. I hope everyone is done with the attendance part. So capacity to ship packages within D days. There is a conveyor belt which has packages that must be shipped from one port to another within days. The ith package on the conveyor belt has a weight of weights I. Each day we load the ship with packages on the conveyor belt in the order given by weights. We may not load more weight than the maximum weight capacity of the ship. Okay. This has the same feeling, right? Let's say enumerate days. I mean, enumerate capacity. Capacity like this: 1, 2, 3, 4, 5, 6. I mean, let's just enumerate it with, let's say you have something like this: 5, 10, 100, 32, 5, 11. Let's just enumerate it with the maximum capacity, which is 100, 101, 102, goes on with sum of a plus 1. Why I'm doing so? Think about it. Why I'm doing so? Less than these values are of no use. Why? Because any value which is less than the maximum weight will never be able to pick the maximum weight. Will never be able to. Okay, I think I. Yes, sorry. I would work now. So I take this as an example. These are my weights, and I'm enumerating my search space. Like for in this example, I enumerated search space like this, right? In this case, I'm saying let's enumerate the search space with the maximum value of weights and sum of weights. Why I'm saying so? Values less than the maximum weight will never be the answer. Why? Because they will never be able to lift the maximum value. Let's say for 99, if the capacity is 99, you will never be able to lift this 100, the the package that weighs 100, right? So it makes a lot of sense to basically enumerate your values with the maximum weight. Okay, till the sum of the weights. Why the sum of the weights? Because if the maximum capacity is the sum of the weights, I could have kept it like infinity. That also makes sense. But why I'm keeping it sum of the weights? Because it's quite obvious that I don't really need a capacity more than the sum of the weights. If I have the capacity of sum of the weights, then I can keep all those weights together on that conveyor belt, right? I hope all of this is making sense to all. So the basic idea, behind keeping this search space, I hope it is clear to all. And now what I need to do is I need to calculate days for any value which is in the middle of it. Let's say the days comes out to be D. And if this D number is greater than capital D, then I know that all of my this half is unnecessary. Sorry, what I'm saying. If this D comes less than, if this D comes greater than the required number of days, I know this half is unnecessary because let's say capacity is 105 and that capacity is not enough. I know that 104 will also be not enough. I know 103 will also not be enough, right? So it also kind of follows an order of monotonicity where if let's say some capacity here is not enough, we know that all the capacities are not enough. And if I ever found a capacity which is enough, yani ki, which means that for that value, the value of D is less than equal to the required D. I know all the values greater than this value will also be a viable answer. So that's how I will reduce my search space. Let's try to. Yes, exactly, Adityan. Like this value, this makes some sense. And I have written the code forehand only, beforehand. Um, let's just try to understand it. See, as we discussed, I have initialized my left pointer to the maximum value of the weights to the maximum value and my right pointer to the sum of the weights. And now this variable calculates days. So this variable calculates days, the D1. I can rewrite to be days. Oops, there is a already. Let's keep it D because there is a variable named days already. So these, if I assume M to be my capacity, I am calculating D variable. Okay, I'm calculating D, and if this D is less than equal to days, then I am putting E equal to M. This is the same feeling, right? Let's have a small discussion about the time complexity of this algorithm. So we know that the smaller loop runs in O of n. We know that this loop runs in O of n. Okay. How many times does this loop run? Think about it. So our code is something like this. There is a while loop which goes till something like this, and there is a for loop which goes something like this. This runs log n times, this run n times. So the loop, so the time complexity of our code is O of n log n. Same with Koko eating bananas, right? And obviously we are not taking any space, so there is no question about the space complexity. It will only be O of 1. I mean, yes, I am just talking about um, the in general terms. This actually is n log a, where you can call a to be equal to sum of weights minus max weight. Actually, this a is always the length of this search space. Okay, so you can also call this size of search space. Okay, I think if anyone have any doubt, they can ask in the chat. And then for those who didn't fill the attendance form, I have floated again. Again, mark your attendance. Will you explain once again? Yes, yes, why not? So this was the problem. I should show problem. Okay. The problem said you had to calculate the capacity to ship packages within D days, and you had to calculate the least capacity to do this work. So we use binary search on answer. We use binary search on answer to solve this problem. We are searching, the search space is the capacity only, right? So this is what we were trying to do. We were trying to search on this search space, we took capacity as our search space, right? And then we are taking one capacity, and now we are checking how many days do we need. If the days come out to be less than equal to D, then we know that answer will be true for all of these halves. So we decrease our search space to this. We remove this search space, we only care about this search space because we are talking about minimum capacity, minimum valid capacity. The capacity is valid. We know the capacity, all the capacity is greater than them is valid, right? So we decrease if we ever find a capacity which is valid, we restrict our search space to this, right? And if we ever found any capacity which is not valid, we restrict our search space to this. Why? Because we know if a capacity is not valid, any capacity less than that will also not be valid, right? That is what we are trying to do. Just let me know if you guys have any other doubt in this problem. Someone says how to master DSA quickly. Just, uh, just like solve a lot of problems. Solve a lot of Don't solve a lot of problems. You can solve 200 to 250 problems in order to get good grasp of DSA. Just solve um, problems having different patterns. That is more important, and try to grasp that pattern. Every problem has its own pattern. Don't try to delve deep into, like, don't try to do a lot of problems of the on the same concept, like you're doing binary search on answer, like you have done 100 problems. Doesn't make any sense if you are trying to find an easy way. So try to prioritize in that way. So is there any doubt in the problem we did just now? If there is no doubt, we can move on to the next one. Shall we do one more problem of binary search and answer? Shall we start with, let's just do one more problem of binary search and answer. Amlesh, constraints. Why do I always care about constraints? Because see, what are the problems that we have done till now? We have done a problem known as Coco eating bananas, where you had to give the least possible speed with which Coco could eat bananas such that it could finish all the piles, right? So one person would have said to me, okay, Malik, just iterate over all the possible speeds and take the minimum of them. There is no problem in that, right? Is there any problem with that approach? There is no problem. But think about it. If you pay a little attention, you will realize there is a problem. And the problem is that the comp would be, because you're trying all possible approach, it will be O of A into N, which gives O of AN. And sometimes this A is 1e9 and this is 1e5. 10 raised per 14. Will this work? Nope. So, but if this O of an approach would have worked if this is 10 raised power 3 and this is 10 raised power 3, then this approach works. So it depends on the constraints whether you need to think of a better approach or not. Sometimes if the constraints are too relaxed, then there is no need to think of a better approach, right? So, why to worry about so many things? Everyone acts rationally, right, for themselves. So we will also act rationally and first think about, we will first see the constraints and then we will see in what direction we have to think. Okay, so try to read this problem, everyone. We have now starting to solve some hard problems of lead code. This is split array largest sum. Given an integer array nums and an integer k, split nums into k non-empty subarrays such that the largest sum of any subarray is minimized. Return the minimized largest sum of the split. Okay. Okay, so try So what I was saying was try to think about this problem. We will be discussing about this problem in the next session. This was the problem. I will put it in the chat. Problem. This session is over here only. We will meet tomorrow at the same time for the last day of the session. We will be talking about some hard problems involving sliding window and some more problems which include monotonic stacks. Right? So we will meet tomorrow at the same time. Till then, bye bye everyone. Take care.